Okay, so how to count pieces by weighing them. So that molar mass, the number of grams in 1 mole, and there's 3 kinds of pieces. There's atoms, there's formula units, and there's molecules. So we're going to make conversion factors out of these facts. 1 mole is so many pieces. 1 mole is so many grams. The number of pieces doesn't change. The number of grams does, depending on which compound you have. So, we've answered questions like this before. We did the grams to moles parts before. So, we just didn't do it with compounds. How many moles is 5.6 grams of NaOH? So they want to know moles, they want to know how many pieces. Just in groups instead of individual pieces. This would be the equivalent of like how many dozen eggs in 45 pounds of eggs? How many dozen do you have? Let me start off, like all conversion factors, by writing down what you know. So we know we have 5.69 grams of NaOH. Okay, so I'm going to put grams on the bottom, moles on top. The one I have goes on the bottom, so it cancels out. The one I can change it into goes on top. So I'm going to change grams into moles. In order to change grams into moles, I need numbers that would fit there. I need to know how many grams 1 mole of NaOH would be, which would be, add up NaO and H. So I looked up on the periodic table, and I found that Na was 22.99 grams. O was 16.00 grams, and H was 1.01 grams. So that brings us to a total of 40.00 grams. It is doing something on its own. Sorry about this. So if you add those numbers up, 22.99 and 1.01 is 24. 24 and 16 is 40. So 1 mole will weigh 40 grams. So those numbers we've been adding up are how heavy 1 mole is. So the number that's going to go next to mole up in my conversion factor is 1. And the number that goes next to grams is 40. And when you push those buttons, 5.69 divided by 40 is, and I got 3 digits there, so I want about 3 digits in my answer. So I get 0.142 moles of NaOH. So what you were figuring out over the weekend when you added up how many grams is 1 mole, what you're figuring it out was you're making your own conversion factor. The number next to moles is 1. The number next to grams is the number off the periodic table added up. If there's only an element, you can go straight from grams to moles because you don't have to add up anything. So let's try a few. How many moles is 4.56 grams of CO2. And this gives you a way of checking on the bell work too. So they want moles, they give you grams. Okay, well, unit I want to get rid of is that grams of CO2, so it goes on the bottom. The unit I want is moles of CO2, so it goes on top. And 1 mole is, well, I got to add up the numbers like you did on the bell work, so 1 C and 2 O's. Carbon on the periodic table is 12.01 grams. Oxygen is 16.00 grams. So that adds up to 12.01 grams of carbon, 32.00 grams of oxygen. So that's 44.01 grams altogether. That should have been your bell work answer today. And I put that 44.01 grams next to grams. And then I divide. 4.56 divided by 44.01 equals, yeah, I got 3 numbers there, so I want about 3 in my answer, so 0.104 moles of CO2. So the numbers you're figuring out are your conversion factor. That's why you're adding them up. So another one. How many grams is 9.87 moles of H2O? So now my conversion factor is different because now I want to get rid of moles, so moles goes on the bottom. Moles I can turn into grams. And 1 mole is, well, 2 H's times 1.01 grams is 2.02 grams of H. 1 O at 16.00 grams is 16.00 grams of O. I add those up and I get 18.02 grams altogether. So that 18.02 is what goes next to grams. So I put the units in first, it tells me where to write the numbers. So 9.87 times 18.02 is, I got 3 digits, so I'm going to say 178 grams of water. Extra hard. Okay, so we said we're going to count, right? Doesn't look like I've counted doesn't look like I've counted atoms or molecules yet. All I've done is this mole thing. How is that accounting? Well, it is counting, and you'll see, but the numbers just get too big if we don't use moles. So how many molecules in 6.8 grams of CH4? Well, I want to get rid of grams of CH4. Can I turn grams of CH4 into molecules? No, I can't. I don't know the numbers. I don't know how many molecules are in a gram. But I know how many I can figure out how many moles there are in a gram, or how many grams there are for a mole. So I need to go from grams to moles, because moles is the number of pieces. Then I'll be able to take that mole and turn it into the actual number of pieces. So I've got C and 4 H's. The carbon's 12.01 grams. The hydrogen's 1.01 grams off the periodic table. So that gives me 12.01 grams of carbon and 4.04 grams of hydrogen. That adds up to 16.05 grams altogether. One carbon at 12.01, 4 hydrogens, that's 4.04. 4.04 and 12.01 is 16.05. And that number's next to grams. So I put the 16.05 next to grams. But that doesn't answer my question. That would be like where we're at right now is if I said you had 10 pounds of eggs, and each dozen weighs 2 pounds. Your first step would be to say, I've got 5 dozen eggs. Right? I got 10 eggs, 10 pounds of eggs, 2 pounds for a dozen eggs. That tells me I got 5 dozen eggs. That's where I'm at math-wise right now. Mole is like dozen. And then change that dozen eggs into how many actual eggs. You'd say, oh, well, 1 dozen is 12 eggs. Well, what is 1 mole? What is 1 mole? 1 mole is 6.02 times 10 to the 23rd pieces. And the piece for CH4 is a molecule because it's molecular, all nonmetals. So that cancels out my moles of CH4. So 6.8 divided by 16.05 times 6.02 EE23 equals I got 2 numbers, so 2.6 times 10 to the 23rd molecules of CH4. This took 2 conversion factors because I had to take the grams and change it into moles, and then I can take the moles and change them into pieces. We did this with atoms back last semester. But it's only atoms if the piece is an element. If it's a compound, it might be a molecule, molecular, or it might be a formula unit, ionic. So all the ones that you use prefixes for in the names, those are molecules. All the ones that you have to think about Roman numerals, those are formula units. Does that make sense? Yeah. 6.8 divided by 16.05, because it was on the bottom, times 6.02 EE23, because it was on the top. So all the numbers on the bottom you divide, all the numbers on top you multiply. Well, the EE takes care of the 10. So if you push that special button on your calculator, it takes care of that 10.
But like if we know that the 10 times that this is at the second part, so we can just like.
Oh, you go ahead and just do that front part. Yeah. But then you're going to worry, if you push into your calculator, it'll automatically adjust the exponent. This one didn't multiply out to be bigger than 10, right? So because of its size, it didn't change the exponent, but the exponent's going to change most often. Because if you have 75 times 6.02 times 10 to the 23rd, 75 times 6 is going to be bigger than 10. So that you'll get 10 to the 24th instead of 10 to the 23rd. We'll see if we find some examples of those. Okay. Okay. And now for the extreme. How many atoms are there in 4.9 grams of NaNO3? Oops, it's not two-sided. It's the flip side I want to give you. We need this because the diagram at the top is going to be a map of how to do all these problems. So this is your homework with a map on the top. Yeah. Which calculator do you have? It's the one that says EE, so you push the second and E.
And so we just have to put like 10.
No, you don't even have to push the 10.
You
Don't push.
need a 10.
Don't even touch the 10. It gets built into that EE. So you push 6.02, second EE 23.
So not time.
Not times, not 10. It's all built in. Okay. So, to do this, okay, I've got 4.9 grams of NaNO3. Okay. I want to get rid of grams of NaNO3, so it goes on the bottom, and grams I can turn into moles. And 1 mole is, I got to figure that out. So I have 1 Na, one N, and 3 O's. 1 Na is 22.99 grams. 1 N is 14.01 grams. So those two together add up to 47. And oxygen 16, I got 3 of them. So 3 times 16 is 48. And 48 and 47, last time I checked, was 95. It's only 85, sorry. Borrowed one too many times. 85. Okay. So 85 grams is 1 mole. Now I want to get rid of moles of NaNO3. And the reason why I turn to moles is so I can turn to pieces. But what is the piece of NaNO3? What kind of piece is it? Is NaNO3 an atom? It's a compound. It's a bunch of atoms, right? So what kind of compound is it? Is it ionic or is it molecular? Does it have a metal in it? If it's got a metal, it's ionic. If it's ionic, the piece is a formula unit. The type of piece changes, the number of pieces doesn't change. Okay? Just like a dozen eggs and a dozen donuts have the same number of pieces, but they don't have the same kind of piece. So 1 mole is always 6.02 times 10 to the 23rd. Just depends on what kind of piece it is. Okay. And then I'll be able to take formula units and change into atoms, because I know how many atoms there are in a formula unit. There's an Na, there's an N, and there's 3 O's. That's a total of 5 atoms. 1 Na, 1 N, and 3 O's is 5. Or, down here, 5 atoms in one formula unit. So 4.9 divided by 85 times 6.02 times 10 to the 23rd times 5 equals 1.8 times 10 to the 23rd atoms. Okay. Okay. I type 4.9. Then I push divided by 85. Then I push times 6.02. 6.02 E 23 times 5.
Oh, okay, I know what I forgot.
You got it? Figured out where it went?
But here it says 1.735.
Mine says, oh, you know, my zero's missing. I'm sorry. My zero's missing. I typed it, didn't show up, so 1.73, so 1.7, sorry. My zero didn't type in. All right, so if you look at that diagram, okay, if you look at that diagram, you'll see that this is not working. Let's try that. It's not working. All right, so that diagram on the top, if you look and see, we started off with grams, and we wanted atoms. So I took the grams, and my first conversion factor was to take those grams and change them into moles. Okay? Then I took those, and to turn that in, grams to moles, I got the number off the periodic table. Then I could take those moles and change them into the kind of piece it is. In this case, it was a formula unit, and I used 6.02 times 10 to the 23rd. And then I went from the pieces, from moles to pieces. From formula units to pieces, and I counted. Okay, so the double-headed arrows are what is going to be in your conversion factor. Okay? Okay, and if you look at that, it says 1 mole is, and it tells you 1 mole is all those 6.02. It's going to be atoms if it's an element. It's going to be molecules if it's a molecular compound. It's going to be formula units if it's an ionic compound. Okay, so the way to get good at this is to do it. So try some. There's a few of you that need to turn in a notebook. So